Hi guys, in this video we're going to have a look at bearings. So in this particular one we're going to have a look at when they're not drawn to scale. So if you wanted to do how to measure them and draw them, I'm going to do another video where it's drawing bearings, but in this case they're not to scale. Okay, so we don't use a protractor to measure any angles here. We have to think of something else. But before we get started, there's 4 things you must remember when dealing with bearings. The first one is that we always start from north. The second one is we always go clockwise. The third one is the starting point is always where it says from. If that doesn't quite make sense, it'll be clear in a minute. And the last one is bearings always have 3 figures. So if the angle, for example, like down here is 40, or the bearing is 40, we actually say it's 040 degrees. Okay, so it must always have 3 figures. So throughout this whole video, I'll be abiding by those 4 rules, which you have to remember. Okay, so let's get started then and have a look at some examples. So this is the first one where I've got point A and point B. I've drawn my north lines because that's where I'm always going to be starting from, and I've been given this angle here of 040 degrees, or this bearing of 040 degrees. So the first question is, it wants to know the bearing of B from A. So I'm going to underline this from A because it refers to this rule 3. Because it's from A, that's where I'm starting from. So I'm starting at A and I'm going to B. So I'm going to abide by these rules. I'm going to start from north. I'm going to turn clockwise. I'm starting at the right point, so I'm going clockwise. So that is my angle. Now it just so happens, in this particular case, that it's been given to us already. So it's 040 degrees. Remember, it's 040 because it's 3 figures. Okay? The next one is, what's the bearing of A from B? So in this case, I'm starting at B and I'm going to A. And again, I'm going to use point 1. I'm going to start from north and I'm going to go clockwise until I get to my direction that I'm going towards A. So this is the angle that I now need to work out because that's my bearing that I need. Different ways you can do this. Essentially, you need to remember it's parallel lines. So if I just rotate this round, you can see that because I've got north, and if you were to extend this, like so, of course, you'd have south and south. So the key thing to remember with bearings is that you've also got 2 sets of parallel lines. So if you're unsure about parallel lines, make sure you check out my parallel line video. But that's going to be crucial for working out these angles. So like I said, there's 2 ways you can do it. We can use the interior rule, like so I'm highlighting here, and say that this angle here of 40 and this angle here must add up to 180. So if that's 40, this must be 140. In which case, because it's round a point, i.e. 360 degrees, what I can do is do 360, take away 140, which will obviously leave me with 220. So this angle here, or the bearing, will be 220 degrees. So that's one way of doing it. You can use the interior rule like that. The second way to do it is go, okay, well, if that's the north and south line, this angle here must be 180, and then 40 would be alternate to this angle here. So 40 would also be alternate to this one here, 40. Then you just do 180 plus 40 to get the 220. So there's 2 different ways you can do it. You can use the interior rule to find out the angle you don't want, and then take that away from 360, or you can use straight line 180, and the fact that you use the alternate rule with the south line there to work out that's 40. So it's entirely up to you. Don't mind which one you use. Next example here, exactly the same thing. Point A, point B, north line, north line. This time I've been given that angle there as 160. So the first question is, what's the bearing of B from A? So from A, so I'm at A, north clockwise. So that is the bearing that I'm after. That's the angle I'm after. So again, I'm going to use my interior rule, which says that this angle and this angle must add up to 180. So that's 160. This must be 20 degrees. So notice I'm putting 020 because bearings always have 3 figures. So that one's there, 20 degrees. Next bit, bearing of A from B. This time I'm at B. Again, north, clockwise, That's what I want. That's the bearing that I want. Now, I've already been given that's 160, so just like I did over there, what I'm going to do is I'm going to do 360, which is all the way round. I'm going to take away the angle that I don't want, which is that 160. No prizes for getting that one. 200 degrees. Okay, so 200 degrees would be the bearing of A from B. Exactly the same process here. I've got my point A, got my point B, and I've been given this angle here is 260 degrees. So you might notice I'm missing a north line, so if I had a ruler I'd use it. I'm going to put my north line on like so. Bearing of B from A, so from A going to B, north clockwise. That's the angle, that's the bearing that I want. So again, I know all the way around is 360 degrees, so if that's 260, I can just do 360 minus 260, and again, no prizes, it's 100 degrees. Deliberately pick nice numbers. And this one here, bearing of A from B, so from B going to A, north clockwise, that's the angle I need. And if that's 100, using the interior rule again, I can figure out that that's going to be 080 or 80 degrees, in which case I can just do 360 minus 80, and that's going to give me 280 degrees. So that's my bearing there. Again, you can use the fact that use the alternate rule, but for these ones, I think it's just easier using the interior rule to help me. Okay, so there's 3 examples there. Let's get just a little bit trickier. So don't be put off. I've got C, S, and L. Okay, so don't be put off. Again, I'm missing my north line, so I'm just going to quickly nip on some north lines to make it easier to spot my parallel lines. And this time I've got no angles on here, but I'm told the bearing of S from L, so that's where I'm at L, is 300. So from L going to S, starting at north, going clockwise, that angle there, I'm told is 300. That's what that sentence there means. So happy days, dealt with that. The question, find the bearing of L from S. So from S going to L. So I want north clockwise. That's the angle that I want. So again, I'm just going to use the interior rule and find out what this one is here. Well, if that's 300, to get to 360, this must obviously be 60, so 060. And then using the interior rule, if that's 60, to get to 180, that must be 120, in which case the bearing from S going to L must be 120. Okay. So in this case, C is actually completely irrelevant, just there to throw you. Same diagram, slightly different question. Again, I'm missing my north line, so I'm going to bung them on so I can spot my parallel lines. And again, no information on the diagram, it's all in the actual question. The bearing of C from S. So I'm at S, this time I'm going to C, and so I start at north, I go clockwise until I get to C, which is there. So that's the bearing, which we're told is 200 degrees. The question, find the bearing of S from C. So this time I'm at C, going to S. I start at north and go clockwise. That's the angle that I'm trying to find. So again, I'm going to work out the missing one here. Well, if that's 200, to make 360, that must be 160. And using the interior rule, that one must add up to 180. So this one here must be 20 degrees. Notice again, I'm still doing 3 figures. So the bearing is 020 degrees. Okay. And the very last example I've got here, try to make it a bit more interesting. We've actually drawn a triangle. I've got some values in here. I'm just going to go through part A. So I want to know the bearing of Y from X. So again, from X going to Y, so north clockwise. That is the first one I need to work out. So using the interior rule, if that's 70 degrees, These two add up to 180. This must be 110. So the first one is 110 degrees. Part B, it wants the bearing of x from z. So there's z going to x. So from z north clockwise, I need to work out that angle. Well, if that's 110, that's 120. I can work out this missing angle here. These two, so 110 plus 120 will equal 230. Take that away from 360. Leaves me with 130. So this angle there would be 130. And then using the interior rule again, that's 130. Obviously need to get to 180. So this must be 50 or 0.50. Okay. So if that's that's 130. That's going to be your 50. So remember, the bearing of x from z, so from z north to x, that's going to be 0.50 degrees. Okay. Now, the next one, bearing of z from y, so from y going to z, north clockwise, I need to work that out. Now, I don't know what this missing bit is here, but if you notice, I have a triangle, and angles in a triangle add up to 180. So if this is 120, plus 40 gives me 160, what's left? That must be 20. In which case, to work out this missing angle here, which is my bearing, all I need to do is add these two together. So 70 add 20 is 90, and then I can do 360 minus the 90, which gives me 270 degrees. So this angle here, the bearing of of z from y, is 270 degrees. So I've used a little bit of angles in a triangle to help me with that one. Okay, so again, hopefully that helps for homework and revision. Cheers.